First questions on test 3 have to deal with sample space and the concepts of both or complements. First thing we were asked is a single 6-sided die is tossed. List the simple events in C if C is roll of 1. So to understand what they really want here, you got to understand what the sample space is. The sample space for rolling a die is 1, 2, 3, 4, 5, and 6. We're trying to say, of these 6 possibilities, how many fit event C rolling a 1? Well, this is the only one that fits. For that reason, the answer is just 1. Number 2 asks, a sample space consists of event 1, event 2, event 3, event 4. They further define events A as event 2 and event 3, and event B as event 1 and event 3. First question they ask is what happens in both A and B. Both A and B is another way of saying the intersection. We're looking for only events that occur in both of them. E2 occurs in A, it doesn't occur in B. E1 occurs in B, it doesn't occur in A. So neither of those count. The only thing that counts is E3 because it appears both in A and in B. So for both A and B, it would be E subscript 3. Hopefully you've gotten enough practice doing these subscripts that you know how to use it with math type, but be very careful, especially if you're listing multiple ones, about where your comma is, that the comma is not on the subscript line. Make sure that you understand how the system wants these entered. For A or B or both, A or B or both includes everything in either of them. So I see E1 and B, that counts. I see E2 and A, that counts. I see E3 in both of them, that counts, but it only counts once. So you don't ever double count something, but you include anything in either group or both. This is another way of saying the union. Not B, we go to the sample space and we compare it to B. The sample space has 1, 2, 3, and 4. B has 1 and 3. So the things that are in the sample space that are not in B are E2 and E4. So for not B, it would be E2, comma, E4. Question 3 asks us to look at one of these two-way tables. It's one of the ones that's done with proportions, so it's not as important that we get the totals right away because we know it's going to total to 1 here, but it's still probably something where you want to do the rows and columns before you begin. So 0.45 plus 0.12 gives me 0.57. 0.03 plus 0.40 gives me 0.43. 0.45 plus 0.03 gives me 0.48. 0.12 plus 0.40 gives me 0.52. No matter whether I add these across or these down, either way I should get to 1, meaning yes, we have 100% of the possibilities in the table. When I'm asked in A, what's the probability if a randomly selected adult comes from this table that that adult needs eyeglasses? That's based on the need eyeglasses row. Yes, that row total is 0.57. For B, they need eyeglasses, but they do not use them. So need eyeglasses, but do not use them. Here's my yes, need eyeglass. Here's my no, do not use them. Where these two meet is at that 0.12. I should remind you, when it's done in proportions like this, we're not dividing by anything, because really the table total is the 1 here. If this wasn't done in proportions and it was done in raw numbers, we need to remember that each of these answers need to be divided by the table total. For part C, it asks what's the probability they use the eyeglasses. So use eyeglasses as columns. Here's the yes, they use eyeglasses. 0.48 is the probability that they do use them. D asks what's the probability they use eyeglasses but don't need them. So we're looking for yes, use eyeglasses, meaning no, they don't need eyeglasses. That's this single cell right here, which has probability 0.03.